Snyder et al. Suggest that caffeine's ability to bind to A1 and A2 receptors can be at least partially attributed to which of the following? The reference is here in the first paragraph. Like many other agents that affect neuron firing, adenosine must first bind to specific receptors on neuronal membranes. There are at least two classes of these receptors which have been designated A1 and A2. The significant reference, the key to answering this question is in the last statement, especially in the first part. Snyder et al. Proposed that caffeine, which is structurally similar to adenosine, is able to bind to both types of receptors, which prevents adenosine from attaching there and allows the neurons to fire more readily than they otherwise would. The key phrase is this one. Snyder et al. Proposed that caffeine, which is structurally similar to adenosine, is able to bind to both types of receptors. So at least a partial explanation is that it is structurally similar to adenosine. Adenosine, which normally binds to these receptors, caffeine being similar to adenosine can also bind to these receptors. Option A says the chemical relationship between caffeine and phosphodiesterase. This is outside the premise of the question, because if there at all is a relationship between caffeine and phosphodiesterase, which there isn't, we don't need to check that further. Phosphodiesterase is a reference from the second paragraph. So first off, such relationship is not mentioned in the context that we require. There's no connection between phosphodiesterase and the receptors A1 and A2, first off. Second off, we can see that phosphodiesterase and its effects is a part of the older theory of caffeine's effects. And Snyder and his team and his group, they have differed from, they disagree with the older theory as it is mentioned in the second paragraph in this line here. So this is completely irrelevant to the premise of the question. Option A can be eliminated. Option B states the structural relationship between caffeine and adenosine. This is perfect because we were looking for this reference. Caffeine, which is structurally similar to adenosine. Now, of course, similar and relationship, they are somewhat interchangeable in this particular context. So we have a structural similarity between caffeine and adenosine. And this option generalizes it and says the structural relationship between caffeine and adenosine. That's perfectly all right. This generalization doesn't change the essence of the statement given here. So B can be qualified. Option C tells us the structural similarity between caffeine and neurotransmitters. We have neurotransmitters mentioned here, but we can see from this first paragraph that no similarity between caffeine and neurotransmitters is mentioned. We do have the similarity with adenosine mentioned here, but it is not stated anywhere in the passage, in fact, that caffeine is similar to neurotransmitters. In fact, caffeine is something that acts on neurotransmitters, which we can infer from the last line. Adenosine normally depresses neuron firing. It does this by inhibiting the release of neurotransmitters. Caffeine, which is able to bind to both types of these receptors, prevents adenosine from attaching there and allows the neurons to fire more readily than they otherwise would. So that is, they increase the release of neurotransmitters, or at least allow the release of neurotransmitters, which means that this is something which is baseless. It cannot be justified by the information given. So C can be eliminated. Option D says the natural occurrence of caffeine and adenosine in the brain. This also is incorrect. We can see adenosine normally depresses neuron firing in many areas of the brain. This suggests that adenosine is a naturally occurring substance in the brain, but caffeine is the stimulant in coffee, and coffee is not naturally produced in the brain. If coffee were naturally produced in the brain, so many of us would not be caffeine junkies or addicted to coffee as such. So this does not work at all. If we are perfectly technical, absolutely technical, then we would say that let's not bring any outside information into the passage and say that we are not sure if coffee or caffeine is produced in the brain. If caffeine is produced in the brain, naturally occurring in the brain, such information is not given in the passage. So at best, this is not specifically certain. At worst, this is absolutely ridiculously wrong. So D can be eliminated. The correct answer is option B.